Hello everyone, welcome back to Mikebaba-CATIA. Today I'm going to show you a high-level professional technique in CATIA, how to link a standard U profile to an Excel design table. This will save you hours of work when dealing with similar parts. Don't worry, we'll do it step by step. Let's dive into the tutorial.
I got this magic in my fingertips, designing dreams with every click. Shapes and wonders come into life. With CATIA I cut through strife. In my mind the future's clear. No more doubts, no more.
Hello to everyone who follows my channel. Today I want to explain one of the most professional ways to use CATIA software. Many times in the industry we use similar parts. For example, similar drill bits with different dimensions, or bottle molds with the same shape but different sizes, or construction profiles with the same cross-section shape. To draw these profiles, we can draw each one separately, or we can create one profile and connect it to a table. By choosing from the table, we can change the dimensions of the profile. This method is very important and valuable when designing similar parts. Suppose I want to draw a U-channel section. I want to connect this section to an Excel table. Then I can select different dimensions from that Excel table. First, I must draw a U-channel profile in the Sketcher workbench. I am using the standard Stahl table. In this table, several dimensions are important: total height, flange width, web thickness, flange thickness, and internal radius. You should consider a few points here. First, the initial sizes you choose for the U-channel do not matter at all. You can give any value to the parameters I mentioned above. Just remember to keep the proportions correct. Your sketch must be fully constrained. Test the sketch at every step of adding constraints. Second, you must choose specific letters for your dimensions. These letters are assigned to the U-channel dimensions. Note that CATIA software is case sensitive. I suggest using the letters from the Stahl table. In the Stahl table, H is for height, B is for flange width, TW is for web thickness, TF for the flange thickness, R is for the radius. I activate the profile command. I will start drawing the U-channel based on the Stahl table. I draw the inner edge of the flange with a slope. This makes my model match reality for engineering calculations and stress analysis. Note that for simplicity, you can draw the flange edge straight. First, I set the main dimensions: height, flange width, and web thickness. Now I set the width for the opposite side of the U channel. I double click on the dimension. A window called Constraint Definition opens. You will see an option called Value. Next to it, there is a box showing the numerical value of the selected flange. I right-click inside that box. A drop-down menu opens. The first option is Edit Formula. I click on it. The Edit Formula window opens. First, I go to the Specification tree. Under the Sketch submenu, I open the Constraints group. I find the name that refers to the first flange dimension. I click on it. I click OK in the Edit Formula window. You will see a black FX icon next to the selected dimension. Now I need a construction line to define the flange width. This vertical line must be at a distance of half the flange width from the outer vertical edge. First, I draw the line as a construction element. Hold the Shift key while drawing the line. This prevents the software from adding extra constraints automatically. Then click on the line and give it a vertical constraint. Now I activate the Constraint tool. I select the two outer edges of the U channel. Before clicking to place the dimension, I right-click. I select the Symmetry option. Then I click on the vertical construction line. Now, no matter what the flange width is, this line will stay in the middle. I activate the Quick Trim tool. I erase the top and bottom parts of the construction line. Only the parts between the inner and outer edges of the flange should be remain. I activate the Dimension tool. I measure the construction line at the top flange. This defines the flange thickness. There is no need to dimension the thickness of the bottom flange. Since I made the inner and outer edges of the flanges symmetrical, the thickness of the bottom flange will change automatically with the top one. Now I change the length of the top flange. I check if the construction line and its dimension move correctly. I also check if the thickness remains constant. Now using the Dimension tool, I set the angle between the inner and outer edge to 5 degrees. Note, in this lesson I kept this angle constant. However, in the Stahl table for width up to 300 mm, the angle is 8% of the flange size. For sizes larger than 300 mm, the angle is 5% of the flange length. In the future lessons, I will show you how to write the formulas for these changes. I activate the fillet tool to round the inner top corner and dimension it. I also round and dimension the bottom corner with the fillet tool. I make the bottom fillet side dependent on the top fillet. An FX symbol will appear next to it. Now I make the inner and outer sides of the flange symmetrical relative to the horizontal axis. Now I move the sketch. I test its freedom of movement. I see that it only moves horizontally. I set the distance of the vertical edge relative to the vertical axis. The sketch turns completely green and is fully constrained. Okay, so far we have drawn our sketch properly. Now we must assign the correct letters to the main dimensions. I right-click on the main dimensions in the sketch. I select Properties from the menu. I click on the Feature Properties tab. In the Feature Name box, I type the desired letters. I click Apply and then OK. Currently, the numbers whose name we changed to letters have not changed visually, but that is not the case. Their names have changed, but they are not displayed on the drawing. In the design tree, under Constraints, you can see the names have changed. Of course, you can change the software settings to show these letters on the dimensions too. I will explain that in future lessons. Now this sketch is ready to be connected to an Excel table. I repeat, so far we have only prepared the shape for the table connection. Now I go back to the Part Design workbench. In this environment, there is a tool called Design Table. I point to its icon with the mouse. I click on it. A window called Creation of a Design Table opens. In the name box, I choose a suitable name. Below that, there is an option, Create a design table with current parameter values. I activate this option. I do not touch anything else in this window. I click OK. A new window called Select Parameters opens. In this window, there is a filter option. If you click it, you will see different modes. You can see all or length mode. This window has two sides. On the left side, it lists all elements from the specification tree. Scroll down to find the dimensions you renamed, or search for the names in the filter box at the top of the list. Now find all 5 dimensions and move them to the right side window. Remember, next to each name, like age, there are 3 other words. We do not need 2 words, mode or activity. We only want length or offset. So we are looking for text like sketch1/age/length/ etc. or text like sketch1/r/offset/ etc. Try to select them in the correct order. When you have moved all desired dimensions to the right window, click OK. A window opens. Choose a name for the file and a location to save it. I click Save. A window called Design Table Properties opens. This window looks like an Excel sheet. You can now see the dimensions and numbers you use while drawing the sketch. At the bottom of this window, there is a button called Edit Table. I click on it. An Excel file opens for us. The first row contains the addresses of the CATIA parameters. Important note: you must never swap the positions of the columns. If you do this, CATIA will not be able to read the columns it created. Therefore, you must select dimensions in the correct order at the beginning in the Select Parameters window. The second row contains the numbers we gave to our shape in the sketcher. We don't change this row. We start entering new numbers from the third row. I enter the numbers according to the standard Stahl table. Now to give each row a proper name, I right-click on the first column, which is A. I select Insert from the menu. A new column is created before column A. In the rows below, I write the standard name of each profile. In the header of this column, I write part number. Write this name without any spaces. Now I click Save. As a rule, whenever you make changes in Excel, you must save it and close the Excel app. The Excel table closes. I go back to the part design environment. We receive a message about an update. Now look at the specification tree. Under the part name, you should see a new branch called Relations. If you don't see this branch, go to Tools, Options, Infrastructure, Part Infrastructure. In the window that opens, click the Display tab. Find the Relations option. Activate it. Now to test if it works correctly, follow these steps. In the design tree, I click on the plus sign next to Relations. It will open its subset. At the very bottom you will see an icon similar to the graphic table tool icon. Double click on it. You will be transferred to another environment for the first time. Double click on it again. A window opens showing all the rows from Excel. Select one of the rows, click the Apply button and return to the graphical area. Now look at the dimensions on the sketch. You should see the changes applied. Friends, if you don't see changes after clicking Apply, just click the Update command. In this case, the geometry is rebuilt with the new dimensions. Well, today's lesson ends here. This lesson is very important for designing similar parts. Watch the lesson several times. Practice with me. Good luck. Goodbye until the next lesson.